The dawn of the 20th century marked a significant leap in scientific advancements, culminating in the development of nuclear weapons. The concept of harnessing atomic energy for destructive purposes was rooted in the groundbreaking work of physicists like Albert Einstein and Enrico Fermi. Their discoveries laid the theoretical foundation for nuclear fission, a process that releases an immense amount of energy. This scientific breakthrough was swiftly militarized, leading to the birth of nuclear weapons during World War II. The Manhattan Project was a clandestine program initiated by the United States during the early 1940s. This massive scientific endeavor brought together some of the brightest minds to develop the first atomic bombs. The successful detonation of the first nuclear device in the New Mexico desert, known as the Trinity Test, was a harbinger of the nuclear age. The ability to unleash unprecedented destruction in a matter of seconds transformed global military strategies. Nations began to recognize the potential of nuclear weapons, not just as tools of warfare, but as instruments of geopolitical influence. World War II was a pivotal moment in history, marked by unprecedented global conflict and technological innovation. The introduction of nuclear weapons in this period represented a paradigm shift in warfare. The bombings of Hiroshima and Nagasaki in August 1945 illustrated the devastating potential of nuclear weapons, leading to Japan's surrender and the end of the war. These events underscored the strategic advantage of nuclear capability, forever changing the landscape of international conflicts. The decision to use nuclear weapons against Japan was driven by a complex interplay of military necessity and political strategy. Proponents argued that the bombings would hasten the end of the war and save countless lives that would otherwise be lost in a prolonged conflict. Critics, however, questioned the ethical implications of targeting civilian populations and the long-term effects of radiation exposure. The aftermath of the bombings revealed the catastrophic consequences of nuclear warfare. The images of Hiroshima and Nagasaki became enduring symbols of nuclear horror, galvanizing movements for disarmament and non-proliferation. The Cold War era was characterized by a tense standoff between the United States and the Soviet Union, two superpowers armed with vast nuclear arsenals. This period was marked by an arms race, as both nations sought to outdo each other in nuclear capabilities. The doctrine of mutually assured destruction, or MAD, became a cornerstone of military strategy, positing that the threat of total annihilation would deter either side from initiating a nuclear conflict. The Cuban Missile Crisis of 1962 exemplified the precarious nature of this nuclear brinkmanship. For 13 days, the world teetered on the edge of nuclear war, as the United States and the Soviet Union faced off over the installation of Soviet missiles in Cuba. The crisis was ultimately resolved through diplomatic negotiation, highlighting the importance of communication and compromise in averting disaster. Throughout the Cold War, numerous treaties were negotiated to limit nuclear proliferation and reduce the risk of accidental conflict. The Strategic Arms Limitation Talks, known as SALT, and the Anti-Ballistic Missile Treaty were pivotal in curbing the arms race. Despite the end of the Cold War in the early 1990s, the legacy of this era persists. The dissolution of the Soviet Union did not eliminate the threat of nuclear conflict. Rather, it introduced new challenges, such as the risk of nuclear technology falling into the hands of rogue states or non-state actors. In the post-Cold War era, technological advancements have led to the development of more sophisticated nuclear weapons. Modern arsenals include weapons with enhanced precision, reduced fallout, and varying yields tailored for specific military objectives. The advent of miniaturized warheads and advanced delivery systems, such as intercontinental ballistic missiles or ICBMs, has increased the strategic flexibility of nuclear forces. Countries like the United States, Russia, China, and India have continued to invest in the modernization of their nuclear arsenals. This includes the development of hypersonic glide vehicles and other technologies designed to evade missile defense systems. The pursuit of such advancements has raised concerns about a new arms race as nations seek to maintain or achieve strategic parity with their adversaries. Nations such as North Korea have pursued nuclear capabilities, prompting international efforts to curtail their programs through sanctions and diplomatic negotiations. The potential for nuclear conflict in volatile regions remains a significant threat to global stability. As the international community grapples with these issues, there is a growing emphasis on arms control agreements and disarmament initiatives aimed at reducing the nuclear threat. Section 5. Chemical weapons, a parallel threat. While nuclear weapons dominate discussions, chemical weapons are an insidious threat. They use toxic substances to incapacitate or kill. Used since World War I, they cause widespread suffering. The Geneva Protocol of 1925 addressed their use, yet they persist in conflicts today. The Iran-Iraq War and Syrian civil war saw their use. Their ease of production attracts rogue states and terrorists. Monitoring and preventing proliferation is a major concern. Efforts to strengthen the Chemical Weapons Convention continue. Section 6. Theoretical implications of nuclear weapons in space. The prospect of nuclear weapons being deployed in space introduces a new dimension to the discourse on arms control and international security. While the 1967 Outer Space Treaty prohibits the placement of nuclear weapons in orbit, the potential for their use in space remains a theoretical concern. The detonation of a nuclear device in space could have far-reaching consequences, affecting both military and civilian infrastructure. One significant impact of a nuclear explosion in space would be the generation of an electromagnetic pulse, or EMP. This phenomenon could disrupt or destroy electronic systems on satellites and spacecraft, impairing communication and navigation capabilities. The loss of these systems would have profound implications for global commerce, military operations, and emergency response efforts. Theoretical discussions also explore the potential for nuclear weapons to alter the trajectories of asteroids or other celestial bodies. As space exploration continues to advance, the international community must navigate the complex intersection of security, ethics, and scientific exploration. Section 7. Detection technologies in the galactic context. Advancements in detection technologies have enhanced our ability to monitor nuclear and chemical activities on Earth and beyond. The development of sophisticated satellite systems and ground-based sensors has improved the detection of nuclear tests and chemical releases, enabling timely responses and verification of treaty compliance. These technologies play a crucial role in maintaining global security and preventing the escalation of conflicts. In a galactic context, the detection of technosignatures, indicators of technological activity, presents new opportunities and challenges. Theoretical studies suggest that certain technosignatures, such as atmospheric pollutants or radio emissions, could be detectable across vast distances. The James Webb Space Telescope and upcoming observatories like the Habitable Worlds Observatory are poised to revolutionize our ability to detect technosignatures. These instruments will allow scientists to study exoplanetary atmospheres and search for signs of technological activity. The integration of detection technologies into international security frameworks is essential for effective monitoring and response. Section 8. International diplomacy and prevention. The threat posed by nuclear and chemical weapons necessitates robust international diplomatic efforts to prevent their proliferation and use. Diplomatic initiatives such as arms control treaties and non-proliferation agreements serve as vital tools in managing the risks associated with these weapons. The Nuclear Non-Proliferation Treaty, or NPT, and the Chemical Weapons Convention, or CWC, are cornerstone agreements that aim to reduce the threat of mass destruction. Diplomatic negotiations play a crucial role in addressing regional tensions and preventing the escalation of conflicts. Efforts to engage with nuclear-armed states, as well as those pursuing nuclear capabilities, require a delicate balance of pressure and incentives. The role of international organizations such as the United Nations and the International Atomic Energy Agency is pivotal in facilitating dialogue and ensuring compliance with international norms. Confidence-building measures, transparency initiatives, and verification mechanisms are essential components of effective diplomacy. The international community's ability to prevent the misuse of powerful technologies is contingent upon sustained diplomatic engagement and innovation. And Section 9. Innovation as a pathway forward. Innovation holds the key to addressing the complex challenges posed by nuclear and chemical weapons. Technological advancements in detection, monitoring, and disarmament strategies offer new avenues for enhancing global security. The development of cutting-edge technologies can improve verification processes, ensuring compliance with international agreements and deterring potential violations. Innovation is also crucial in fostering resilience against the threats posed by these weapons. Advances in cybersecurity, emergency response, and infrastructure protection can mitigate the impact of potential attacks. Investment in research and development, particularly in the fields of science and engineering, is essential for creating robust defense and response capabilities. Collaborative research initiatives and international partnerships can facilitate the exchange of knowledge and best practices, promoting a culture of innovation that prioritizes peace and stability. By aligning scientific progress with ethical considerations and diplomatic efforts, the international community can chart a course towards a future free from the specter of nuclear and chemical warfare.